Tech It For Me is an independent and solo-produced podcast.
Welcome to the Tech It For Me podcast. I'm Mike Madole. Everyone's talking about large language models these days. GPT-4, Claude, Gemini, but very few people can actually explain what these things are or how they work. Are they just giant autocomplete machines, or are they something more? Do they think? Do they search? Today, we're going behind the buzzwords to break it all down. I'll walk you through how large language models work, from tokens and transformers to embeddings and predictions, in a way that makes sense whether you're an engineer, an executive, or just curious about the future. This is the Tech It For Me podcast. Let's go.
This is the Tech It For Me podcast.
You don't need to know how to code to understand what a large language model is. You just need the right analogy. Think about cloud computing a decade ago. Everyone was throwing the term around, but few really understood it. That didn't stop businesses from investing millions into it. And today, we're seeing the same thing happen with AI, especially with large language models, or LLMs. If you're in a leadership role in IT, HR, operations, legal, marketing, you might not be writing code, but you're definitely going to be making decisions that involve AI tools. Maybe it's approving budgets, maybe it's reviewing vendor proposals, perhaps it's fielding questions from your board about your company's AI strategy. And the truth is, you can't afford to just nod along anymore. Because chances are, someone in your organization is already pushing to bring in AI. Maybe it's a chatbot project. Maybe it's document summarization with Copilot. Maybe someone is using ChatGPT in their daily workflow without you even knowing. And when they say, we could use an LLM for that, most people nod politely and think, that sounds great, but I have no idea what that means. That's not a great place to be, especially when the tech is moving this fast. Now, before we go deep into the mechanics, I want to quickly share my background with artificial intelligence. I hold certifications in Career Essentials in Generative AI by Microsoft, Ethics in the Age of Generative AI, and Generative AI for Digital Marketers. I also am working on a hobby project that embraces AI solutions such as chatbots and AI document management at a cost-effective price point for consumers. So this isn't just a passing interest, it's something I've been exploring from both a technical and a strategic lens. So what is a large language model? At its core, a large language model, or LLM, is a kind of artificial intelligence trained to understand and generate human-like text. But it's not reading or thinking in the way we do. It's using probability to make predictions. And when we say large, we mean massive. These models are trained on data sets that span the entire internet: books, news articles, research papers, discussion forums, Wikipedia, product manuals, marketing emails, social media posts, and more. Some estimates say the most advanced models have been trained on over 1 trillion words, which is the rough equivalent of 12.5 million novels. But here's what's important. LLMs do not memorize facts. They actually learn patterns. They build a statistical model of language, a system that can guess what's most likely to come next based on what it's seen before. So let's take a look at an example. If I say the words, once upon a, you're probably thinking, time. That's prediction. That's pattern recognition. That's exactly what LLMs do, just at a far more sophisticated level. You feed it a prompt, and it continues based on probability. And because it's trained on so much human-written content, the outputs it generates often sound surprisingly natural or even creative. It can write emails, summarize documents, answer questions, brainstorm ideas, and mimic a variety of tones or formats. All of this is possible because it has statistically learned the structure, rhythm, and nuance of language. So when someone says we're using an LLM, what they really mean is We're using a highly advanced system that guesses what comes next in a conversation or a piece of writing with accuracy. And truthfully, nobody's probably going to say, I'm using an LLM. They'll most likely say, I'm using AI, but I digress. The guessing game, as simple as it sounds, is the foundation of some of the most powerful and disruptive technology we've seen in a generation. Let's keep going and break down exactly how these models handle that process under the hood with language building blocks, or more specifically, tokens. Now, if LLMs are built on predicting the next piece of text, what exactly are they predicting? Not letters, not full words, but tokens. A token is usually a chunk of a word, something like a syllable or a root. For instance, take the word unbelievable. Most models would break it down into several tokens: un, believe, and able. So why does this matter? Because language is flexible. People write informally. They misspell things. They mash words together. And a lot of language, especially on the internet, isn't clean or polished. Tokenizing language into smaller units lets the model handle all of that. Think of tokens like Lego bricks. Full words are too big and bulky, but with tokens, the model can snap ideas together at a finer resolution. That gives it more flexibility in understanding and generating language. Now, here's where it gets really important. Every model has a token limit, a cap on how many tokens it can consider at once. Think of it like the model's short-term memory or its attention span. ChatGPT 4o or GPT-4 Turbo, for example, has a context window of 128,000 tokens. It's massive, roughly the equivalent of a 300-page book. It means the model can absorb and reason over a huge chunk of information all at once. Documentation, emails, transcripts, code, even multiple conversations, all in one session. But once you exceed that limit, older parts of the input are dropped or ignored. So if you're feeding in long documents or having extended interactions, you're literally working within the bounds of a memory ceiling. This has real implications for everything from customer service workflows to legal research to internal knowledge bots. If you've ever used ChatGPT and found that it forgot what you said earlier in a conversation, it's probably because you exceeded the token limit. It's not being lazy, it just doesn't have enough room left in its memory to hold on to everything. And this token limit matters a lot for enterprise use cases. If you're summarizing a long report, analyzing contracts, or feeding in a bunch of documentation, you need to know whether the model can handle that volume. Some models truncate input, others drop the earliest parts of the conversation, and some may split documents up automatically, sometimes losing key context in the process. Understanding tokens gives you a sense of the model's constraints. It tells you how much you can throw at it and how much it can retain at once. And when you're evaluating tools or vendors, knowing the token limit can save you a lot of frustration and help you make better architectural decisions. Now that we understand tokens, let's demystify the transformer. And no, we're not talking about Autobots or Decepticons. If you've ever wondered how today's AI models can carry on a conversation, write full paragraphs, or handle translations that actually make sense, it all goes back to a breakthrough in 2017. That year, a team of researchers at Google published a paper titled "Attention is All You Need." In that paper, they introduced a new neural network architecture called the transformer, and it completely changed the game for natural language processing. Prior to transformers, most AI models processed text sequentially, reading one word after another in order, like a typewriter. That worked fine for short phrases, but it fell apart with long or complex sentences. These models struggled to remember or relate words that were far apart in a sentence. The transformer architecture solved that problem using something called self-attention. This mechanism allows the model to weigh the importance of different words in a sentence or a paragraph, regardless of their position. So let's look at another real example. Take the sentence, "She didn't like the movie because it was too long." If you ask, what does it refer to, you'd say the movie, right? Older models struggled with that kind of reference, but transformers can understand that it relates to movie, even though the two words aren't side by side. That's because self-attention lets the model compare every word with every other word, scoring the relationships between them. It's kind of like giving the model a highlighter and saying, focus here, these are the important bits. This ability to understand context across the entire input is why transformers are so powerful. It's also why today's chatbots can actually stay on topic, why AI tools can summarize reports or meeting notes in a way that makes sense, and why models can now handle tasks like translation, writing, or basic analysis with results that are often surprisingly useful. Transformers are the core engine behind all of that. They're the reason models like GPT-4o, Claude, and others can understand relationships in language. They can respond in full sentences and adapt to the context of what you're saying. Without transformers, this level of natural conversation and responsiveness wouldn't be possible. And this also ties back to what I shared previously. The token limit is the memory size, and the transformer is how the model navigates and prioritizes everything in that memory. So if tokens are the bricks, the transformer is the architect, deciding how they all fit together. All right, so now let's talk about the concept of embeddings. This is how the model represents meaning. And while that word might sound a little philosophical, this part is actually very mathematical. The model doesn't understand words the way you and I do. It doesn't know that a dog is furry, or that it chases tennis balls. Instead, it recognizes patterns from how words appear together across millions of documents. So it might learn the word dog often shows up near other words like walk or bark, puppy, leash. You get the idea. The way it captures these relationships is through something called embeddings. Embeddings are just numbers, specifically vectors. Think of them like GPS coordinates. Each word, phrase, or even entire sentence gets plotted in a multi-dimensional space. Words that are used in similar ways, like doctor and nurse, or Monday and Tuesday, end up close together in that space. So if you ask the model, what's the capital of Italy? It doesn't pull out a flashcard labeled Rome. It looks at how the phrase capital of relates to countries in its internal map and figures out that Rome is the most statistically likely answer in a neighborhood around Italy. So let's take a look at another example here. In some early embedding experiments, researchers found that you could do math with words. You could take the vector for king, subtract the vector for man, then add the vector for woman, and get something surprisingly close to the vector for queen. That kind of relationship math is what makes embeddings so powerful. It gives the model a sense of analogy, similarity, and context. So whether you're feeding it legal contracts, customer complaints, or help desk tickets, the model is processing that information by plotting it all into this high-dimensional space and navigating that map when it responds. Embeddings are used in search, classification, recommendation engines, and especially in fine-tuning and retrieval augmented generation systems. In other words, they're the hidden geometry behind how the model thinks. Moving right along, let's talk about model scale and why more isn't always the best option. When we talk about large language models, we're referring to systems with billions or even trillions of parameters. Parameters are like tiny adjustable dials that the model tunes during training to help it better predict the next word or token. GPT-4, for example, has over 1 trillion of these parameters. It's a big part of what makes it so capable. It's been trained on vast amounts of text and has the complexity to handle all sorts of tasks with a high level of accuracy. But a larger model isn't always the most practical choice. Larger models often come with trade-offs. They can be slower to respond. They can be more expensive to run. They require more powerful hardware, and may be harder to deploy in constrained environments. Depending on your needs, a smaller model like GPT 3.5, Claude Instant, or an open source alternative like Mistral might be faster, more cost-effective, and easier to integrate. And with the right approach, you can often close the capability gap between smaller and larger models. That's where retrieval augmented generation, or RAG, comes in. Rather than asking the model to rely on what it learned during training, RAG lets you connect it to live external data, like your own documents, knowledge bases, or internal systems. So if you ask it a question about your company's onboarding process, it can retrieve the exact information from your documentation and generate a tailored answer. Think of it like giving the model real-time access to your organization's library. This setup gives you the responsiveness and affordability of a smaller model, with the context and relevance you'd expect from a much more powerful one. In the end, the best model isn't necessarily the biggest. It's the one that fits your use case, your data, and your operational goals. So, what does this all mean for you? It means large language models are not magic. They're not aware or conscious. They're not doing research, and they definitely don't know anything in the traditional sense. But they are incredibly good at pattern recognition. They've seen so much text, so many examples, and so many ways we as humans use language that they can mimic a wide range of human communication with impressive fluency. That makes them useful across almost every department. In customer service, they can power chatbots and help desks. In HR, they can help draft job descriptions or onboarding material. In legal, they can summarize documents or highlight key risks. In IT, they can write code snippets or help troubleshoot errors. In marketing, they can generate social posts or even landing page ideas. They're already showing up in products you use every day, like email clients that draft replies, office tools that suggest edits, or apps that summarize meetings. But, and this is a big but, they also can hallucinate. They can make things up, especially when asked about things outside their training data or when trying to sound confident. So if you're adopting LLMs in your organization, treat them like very capable interns. They're fast, tireless, and surprisingly creative, but they still need review. Understanding how these models work gives you a huge advantage. You can ask smarter questions when evaluating tools. You'll know when to trust the output and when not to. You can better assess AI risks from data leakage to compliance to reputational damage. And you can help your team focus on real value, not hype. In short, this is your moment to lead with clarity. Not by becoming an AI expert, but by becoming an AI literate decision maker who knows how to separate the signal from the noise. All right, let's bring it all together. Large language models are powerful tools, but only if you understand what they are and what they're not. They're not search engines, they're not fact checkers, and they're definitely not self-aware. They're incredibly advanced systems that generate text based on patterns they've learned from massive amounts of data. They don't know the meaning behind the words, they just get very good at putting the right ones in the right order. We've unpacked a lot in this episode. What LLMs are really doing under the hood, how tokens and transformers work together, why embeddings give them a sense of relationship, and how a model's size, memory capacity, and internal design influence the kinds of tasks it can handle well. More importantly, I've talked about how to apply that knowledge in a business context, so you're not just going along with the hype, but making smarter decisions about how and where to use AI. If you're a tech leader, a department head, or even just someone trying to stay sharp, this kind of understanding gives you an edge. If this episode gave you clarity or sparked ideas, consider sharing it with someone in your circle. And if you have a question or want a deeper dive on a specific AI topic, let me know. I've got more episodes on the way. This is the Tech It For Me podcast. Thank you for listening.
Tech It For Me is an independent and solo-produced podcast.